All right, so let's go through what we're looking at here, and I'll just kind of if you guys have something that's on top of your mind, then just say it. But I'll kind of go through and just ask questions. So I'm assuming all three of you can see my screen, right?
Yes.
Yes.
All right, good. So let's start with all of these are compressors that are lined up in parallel with one another. That's what makes it a parallel rack system. Everything is run in parallel. But let's look at some of the components that we've got on this and just identify what they are. So when we're looking at the front of this compressor, you've got this Centronic on there. What is that all about?
So that's an oil pressure safety switch. If the just below that, you see the round item on the compressor. That's the oil pump, which picks up oil out of the sump and pushes it back through the journal out into the running gear of the compressor. Now, a little bit to the right, it says 404A on it. Yes, right immediately below it. That pumps the oil back through the running gear of the compressor, just like an oil pump in an engine would, to keep those moving parts lubricated. If the oil pressure differential drops too low, we know we're not moving oil to lubricate the compressor properly, and that compressor will lock, that control will lock the compressor out.
Got it. Okay, so what are we looking at over here?
That is an oil level regulator, and that maintains a set oil level in the compressor. There's a little float inside there with a needle valve, and when the level drops, the float drops, and it allows a bit of oil in to maintain that set level.
Got it. Okay, because in this system, everything's sharing the same pot of oil in essence.
Yes.
Got it. Okay, and so when we talk about the head of a compressor, we're talking about this right here, right?
Correct.
And okay, so I'll ask you this, Kevin. I can tell you're already getting bored by this conversation. I'll try my best to keep you entertained. So some people will talk about rebuilding a compressor. I assume you've done that before. So talk about what that entails and involves.
Well, on most of compressors, all you could do is just about valve plates and head gaskets. I mean, most pumps can't be rebuilt in the field unless they're some older Carlisle, different manufacturers. So most of the time, all you could do to rebuild a compressor is pretty much pull the head off and expose the valve plates and change the valve plates and change the head gaskets and the valve plate gasket.
Okay, so that's just a matter of isolating the compressor, making sure you get all the refrigerant out of the compressor, take the head off. This is your head gasket here, and then underneath here, that's where your valve plate is. And if your valves are damaged, then you can replace them there. But obviously, if you have compressor, cylinder scoring issues with your pistons, whatever, then generally you're not going to be able to do much with that.
Yeah, and it depends. Some customers don't even want you opening them up to even rebuild them. They just want a new compressor.
All right, I'm getting another request to show where the oil pump is. So it's right beneath the oil pressure switch. Correct. I've never actually pulled an oil pump on one. I think
your mouse cursor right now is on the oil pump, and just as a little bit, if you slide over to the right a little bit, about where the bottom right-hand corner of the A is, just off the corner there, right there, that is actually the differential pressure switch for the Centronic. The Centronic is mostly just an electronic board. That little module that screws into the side of that oil pump picks up the differential, the difference between the refrigerant pressure in the crankcase and the pump outlet pressure. All it is a little switch, and the Centronic just reads that as open or closed.
Right, and your oil pressure is that differential between crankcase pressure and your oil pressure. And somebody's asking, what is the typical oil pressure that you're looking for?
I'm answering that right now. You would be looking for a 50-pound net oil pressure on a Copeland compressor. I was answering it in the chat, so I'll just answer it this way. On a Copeland compressor, you'd be looking for approximately 50 pounds above suction. So let's say you're measuring a 42-pound suction pressure. You're going to want about 92 pounds oil pump outlet pressure. That's always relative to whatever your suction pressure is. So it's 50 pounds above suction is the oil pressure that you would want to see.
Got it. So somebody's asking here, when the crankcase is under pressure, what's the best way to add oil if needed?
Use your oil pump. It'll pump right through it, no problem.
All right, and then when we're looking at this, we're looking at this particular setup here. You can see down here. What are we looking at down here?
That'd be the liquid shell dryer.
All right, talk to me.
It's going to be filtering your liquid line. Your liquid refrigerant is this is like a liquid line filter dryer, except it's replaceable cores in it. So that would be doing all your filtering.
Right. It's the same kind of dryer that you would see on a like a residential split system. Just instead of cutting the old one out and burning a new one in, we're going to isolate it, pump that refrigerant out, pop those 8 bolts out, and put new cores in and put it back together.
Yep, that's so sorry that I'm pushing you guys to be so basic here, but this is the sort of stuff that I'm telling you, like even every time I walk into a rack house, I have to reorient myself to. And so that's why we're doing all these basics. All right, so we're going to go to the next. We're going to go to the next image here.
Okay.
Ooh, if I can actually figure out where I'm at. Yeah, when I tell my wife that I'm I have a nice rack in my office, she always gets a little nervous, but then she notices what I'm talking about. So that wasn't funny. That was terrible.
I wanted to touch on something I see pop up here in the discussion. And yes, oil discharge pressure minus suction pressure equals oil discharge, or equals oil differential, and it should be 50 psid. That is specific to a Copeland compressor. Other brands of compressors, specifically the Carlisle compressor, will have a lower oil discharge, oil differential pressure. Carlisle's going to want something around 25 to 30 pounds. If you start to see 25 to 30 pounds on a Copeland compressor, you're going to be looking into bearings or a problem with an oil pump.
Yep. All right, so let's look at, I don't remember whose image this is. I think this might be Kevin's. Is this yours, Kevin?
Like Kevin?
Yeah, it's mine. Yeah,
right,
it's mine.
So what do we got going on here?
That would be a 600-pound boat anchor Carlisle compressor that has died about 5 times. That is basically where it's getting changed out. It's getting drug out of the rack and dropped on a roof and then craned off the roof, and then a new one on, and then it's getting picked up and dropped back down in place, and then put back together.
So you field fabricated this setup, or this is something that's on site? This rig for sliding in and out.
Part of it's in my van, like it together in my van, like the original, the beginning frames in my van, and then I kind of piece it together and build it to whatever I need on site. Just kind of taking pieces and whatever I need, however I need to make it adapt to what I'm doing.
So the question from Paul Bunyan and Steve Wright, and I don't know if this is the Steve Wright. I wonder if it is. If it is, then I'm honored to have him here. I don't know if you guys know Steve. He's the current president of RSES. If not, I'm still glad you're here. But if it is, then that's cool. But they're asking what keeps killing compressors. You have any clues?
It's flood back issues, and unfortunately, it's we get contractor to change the compressor, and that is it. And they have their own in-house techs to do everything else, and it's been brought up many times. They don't want to fix it, so we just keep changing the compressors.
Okay. That's a nice use there. What is the name for this? You guys, I think you called it these are called trolleys. Is that right? I'm trying to remember Jeremy's article on this.
Yeah, those are Unistrut trolleys.
Yeah, and you can do so. Jeremy has been a couple years ago wrote a whole series of articles on using Unistrut and other kind of like rigging techniques. One of my favorite articles. I've never really had to do most of the stuff that's on it, but I've seen this sort of set up quite a few times in grocery applications to get them in and out of the van, in and out of the rack house, and it's pretty ingenious. Let's go move on to the next one here. So here we've got another rack. Whose photo is this?
Looks like the one in your office.
Oh yeah. Oh, that's right. I was just sharing the one in my office. Actually, this must be Nathan's photo. And the reason why I know that it's Nathan's photo, we have to be very careful about customer stuff. But if you look up here, you can see on this book up here, this log book, I think that's a Kalos logo. So that's sort of a dead giveaway. So what are we looking at here, Nathan?
I mean, it's a rack. I don't know.
Okay. All right. Well, I mean, you want to give us something interesting because, we're doing a podcast and people like to hear things and, stuff like that.
No, I mean, so this was just a photo of it's an almost 45-year-old rack. after we had done a cleaning on it because it looked real bad beforehand, was why I took the photo. Other than that, I mean, I don't know. There's a good photo of the receiver in it.
There we go. All right, yeah. So let's talk about receiver. Would you have been ashamed if I would have looked at the wrong component? I was like, take a look at the receiver, like I started doing on the oil pump there. It was real embarrassing. I hope nobody noticed that earlier. Okay, so we got a receiver. Talk about the receiver.
Yeah, I mean, so in a rack, you obviously aren't charging by subcool or whatever. You sort of have just a tank of liquid left for, you're sort of basing your charge not on really readings unless you're at zero, which is bad as far as like superheat or subcool. You're basing your charge on how much liquid you have in your receiver, which is what that little gauge is on the front. So it's basically just a pressurized tank of liquid to use as you need it or as load changes.
Okay, so as you have, let's talk about that briefly. So on a rack system, when we say load increases, what do we mean by that?
I mean, it can mean it got hotter outside. It can mean that they're loading big walk-in box, or like right now everything's getting overshopped, so nothing's at temperature ever, and so you're just running much higher load than you would if all the doors were closed.
Okay, so typically in grocery applications, higher load means that you have more heat entering your cases and your walk-ins because people are either leaving doors, opening, closing doors, or putting product in.
Yeah, correct.
I knew it was. Oh boy, man, I'm a smarty. All right, so when you have higher load, what happens to the level in your receiver?
Your liquid level will go down because you're pumping more out to the cases, and so in general, as load increases, you'll see your liquid level drop somewhat significantly. Actually, this particular rack is a little odd in that they have way too large of a heat reclaim for the store to manage humidity, and so it pretty much bounces between 0 to 80% if the heat reclaim comes on, which is just sort of a side thing about this particular rack. But yeah, in general, when load goes up, your liquid level is going to drop. The more things that you have cycled off, or this has electronic EPRs, so the more things that have sort of slowed down, you're going to get a little bit more liquid back in your receiver.
All right, you just said EPR, so yeah, we were going to do heat reclaim. We got a question about that, but Jeremy, go ahead and give us a quick. Actually, I don't know. Do we have any EPR photos in here?
I don't know. So that would be. I tell you what, the way that my young apprentice right now is kind of trying to wrap his head around understanding that is almost like it's a zone control. So on a zoned HVAC system, you would have a damper that modulates the amount of air that each particular zone gets. You could almost look at an EPR very similar to that, where the meat cases are going to want to run at a little bit lower evaporator temperature than, say, a deli or a produce case would. So you can set the rack at a given pressure for your necessary saturated suction temperature. And then you can raise up individual evaporators to maintain a little bit more precise control in those circuits.
So in other words, it controls your evaporator temperature.
Yes.
And depending on whether it is a EEPR or whether or not it has a built-in solenoid, it can also act as a shutoff valve for the circuit entirely.
Yes.
Cool. So that's the basics of an EPR. When you look at a rack, you kind of have your compressor side, which is what we were looking at on the first couple slides. So that's the side where you're basically drawing in suction gas, you're increasing the discharge, and you're sending that out to condensers. Or if you go to the other side of the rack, that's more the suction lines coming back from the cases, or the liquid lines going out to the cases, and that's where you're going to see these EPRs, which really do act as, I don't want to say the primary control, but it's a good portion of the control for each individual circuit that goes out to each case. But I did want to ask you, Jeremy, because they were asking about using heat reclaim. Is that something that you do up there very often at all?
Heat reclaim it's actually gotten less common on a lot of the systems that I deal with. I'm not 100% sure I understand the reasoning behind it. I have a lot of stores that really depend on heat reclaim to maintain temperature and for humidity control in the summertime for reheat. But I think it's just that the prices of gas have gone so low that it costs more to set up a heat reclaim system with the coils and the piping and controls than it does just to run gas.
All right, so Nathan, I'll let you do the review of what heat reclaim is.
So heat reclaim, you're just taking the discharge gas right off the rack and diverting it before it goes through your condenser. You're shooting it through an air conditioning coil somewhere. Well, typically an air conditioning coil, you might use it to heat water too. And so somewhere that you want heat, the application in Florida, because we're always dehumidifying, is after, as sort of a post-heat, post-cooling the air, you then reheat with that discharge gas so that you can increase your runtime and drive humidity down.
Yeah, well, increased runtime is one big factor of that, but also it gives you I guess in that application it's just runtime. Yeah, never mind. All right, so Jeremy says, as far as rule of thumb, I like 20% receiver with a full condenser at normal conditions. So your receiver 20% full with a full condenser in normal conditions. That's what I'm taking that to mean.
Okay, so a little bit of background there, and I apologize if you're not watching the chat. Some guys were asking about split condenser, which we haven't really touched on. But the condenser coil for a rack like we're looking at here could be 10 feet long or more, and 6-7 feet wide. So we use valving to shut off half of that condenser during low ambient conditions. And someone had mentioned that they charged a rack while it was in split condenser, while it had half the condenser valved off and emptied out. When it warmed up and the condenser went into full condenser, his rack dropped to a low receiver level again, which would be very normal because you've got to open that valve up and you still have to have that refrigerant to fill that additional condenser coil space, which is why I said 20% receiver with a full condenser at normal conditions. You would need a higher receiver level, 35, 45%, if you're charging it while it's in split condenser to have that extra gas on hand for when it comes out of split condenser.
Yeah, which is why it's important for your receiver to be sized specific to the application and for it to be charged accordingly. Because obviously, if you have a receiver that when you have full capacity and you have a thing, okay, well, I've got to charge to 50% receiver or whatever, and then you go to to less condenser capacity, you could easily run a condition where you're overloading your receiver.
Correct.
All right, cool. I don't know whose this is. What's going on here?
I don't know whose it is either. It looks like you had a little bit of a frozen coil. So this is looks like the inside of some glass door frozen cases or some kind of glass door cases all opened up so you can see the bottom. It doesn't look super frozen up, though.
So these are EC motors, correct?
Yeah, they're ECM programmable motors.
When you say programmable, what do you mean?
Like you could put a stick or a module, or I think those ones are a stick, in the back of the motor. You could change the RPMs on the motors. So they could put one motor at the factory and do like multiple different applications with it.
And are you having any issues with these motors?
Absolutely tons of them.
Okay. I had heard rumblings.
They're positively allergic to water. If somebody puts the fan or the pans that would cover this up during normal operation, you put that pan in and you get it dropped at the wrong angle, you'll take a wing right off of that blade. Yeah, they're great. They're wonderful.
They're expensive. They're hard to find. So
being that it's unitary, it's almost a OEM only type proposition.
Yeah, and we ran into the same thing in air conditioning. And the thinking is energy efficiency primarily. Is that why we're starting to see more of them?
I think so.
Yeah, I mean it's an energy deal. I mean the amount of money they're saving over an entire supermarket using ECM motors compared to standard shaded pole motors or watt motors. I mean, they're saving a ton of money till they got to replace a bunch of them.
Right. All right, so we're going to move on from this. All right, so what do we got going on here? This is a good one.
This is the right way to pipe gas defrost.
All right, so we've got our liquid coming in here. Mm-hmm. All right, so going into our TXV. And then it's this little doohickey that I think most of us who do air conditioning aren't familiar with. So what are we looking at here?
It's a distributor with an auxiliary side connector. So it's just a distributor like you would see on most any multi-circuited evaporator coil. The difference being it's got a hole drilled in the side and a fitting soldered in. In this case, it can be used in two different applications. It can be used for this, which is a defrost application, or for hot gas bypass, for capacity control. And in this case, you would have hot gas coming in the suction line, going through the evaporator, pushing back through the distributor tubes, which are all nicely frost covered right now, and then going down through that line, leaving the distributor and through a check valve that's off screen and into the liquid line during the defrost cycle. Now, if you flip to the next picture.
Let me make sure it's the next one. There it is.
I saw it when you were flipping around earlier. This is the wrong way to do it, because at the back of that distributor that you can see here, there's the nozzle, which is, in this case, you're probably under 1/8 of an inch port in that, and you cannot get enough refrigerant flow, enough liquid flow through that to get a good complete defrost.
Okay, got it. So when you have the auxiliary on it, it's bypassing that, and versus if it has to come all the way through it, then you're not going to have the right defrost flow.
Right, because the nozzle is generally at the back of that distributor.
Got it. Okay.
It's a matter of the nozzle placement in relation to where you're trying to tap that liquid out.
Okay, got it. And so in this case, it has to go through all of that before it feeds back through. And I'm gonna go back to the other one here. And here, it's able to bypass the restrictive portion and go out. So you have to have a specially designed distributor then, basically.
Correct.
And what do they call that? Is there a name for that?
It's a distributor with ASC, or auxiliary side connector, is what Sporlan calls it.
And what prevents the refrigerant and defrost from just going back this direction, back through the expansion valve?
It's not going to go back through the TXV.
It just doesn't want to.
No, there's higher resistance. We haven't seen, I think a lot of heat pumps do that where they don't have the bypass check valve anymore. They can just backflow through the TXV. I really haven't seen that come into the refrigeration world. Got
it. Eric Vincent says, "What's the vertical copper piece?" I think he's seeing
yes,
this here.
I think that's what he's looking at. So you have, if you look coming off the distributor, you have 3 passes. So there's 3 separate circuits going through the evaporator, okay? And they all come together at that vertical copper piece is a manifold. And they all come together there, and then it enters into that. That's just like, you could call that the beginning of the suction line.
Right. And so under normal operation, it's gonna travel this direction, and this is where it begins to flash, and it goes through, and then it connects back here into this manifolds together, and then it goes down the suction line. In the case of defrost, it's going to go the other direction. Refrigerant's going to come this way, and then it's going to merge back into the liquid going this direction.
Right. It will condense. The hot gas coming down the suction line will condense in the evaporator and be pushed out through that line that's dropping out of the distributor. We call that the dump line, and it will push that condensed liquid out of there, like I said, through the check valve that you can't see on screen here, and back into the liquid.
We have one question that's common in refrigeration. Ariel asks, is it normal to have so much frost?
Absolutely. That is a freezer case. Your saturated suction temperature there is about -15. So if I don't have frost, something's wrong.
Yeah, and that's just simply thinking about when you have product that let's say you want to get your product to, I don't know, -10, for example. Obviously, you have to have an evaporator coil that's lower temperature than that. And anytime you're below freezing, anytime you're below 32 degrees, you're going to get ice. So ice is just a part of the game when you're dealing with low temperature, especially. But even in medium temperature, you will on occasion get some frost as well. So that's just a normal part of what we have to deal with, and why we have to have some form of defrost. One question was no insulation for the sensing bulb. They're asking about why the sensing bulb isn't insulated.
I have never seen a problem with that. I very rarely see a sensing bulb insulated in a refrigerated case.
Yeah, and I think a big reason for that is that your coil temperatures generally aren't that divergent from your case temperature under normal operating conditions. So having a little bit of ambient effect, meaning being affected by the ambient air, isn't that much of a swing in comparison to what you may see in an air conditioning system where it may be affected by return air, which could be significantly higher.
Yes.
So to me, it's all a matter of what airstream it's in. And in the case of being in a case, the temperature of this suction line and the temperature of the air around this bulb aren't going to be that much different. Does that sound plausible?
That makes perfect sense to me.
Yeah. I was making it up as I went. I hope nobody could tell. All right. We did this one. All right. What are we looking at here? I see snow. I see a big boot.
Yeah, that was me.
Yeah, it's a Florida. It's just an average Florida day that we had there. Actually, I think I've got my before and afters mixed up here. Oh, no, I don't have it. Let's see. I don't know. What are we looking at here? I think this is you, Kevin, right?
That was a set of shell dryers that somebody had actually put together wrong. They had the wrong gasket on the face of it, and it was blocking like 80% of the flow.
Okay, well that's bad. Don't do that.
Yeah.
All right, next
So
image here.
that would be the inside of a.
Go ahead. You can finish your sentence.
That would be the inside of what one of those liquid shell dryers looks like.
All right. Now, this is, I would almost guarantee this is you because you always love taking screenshots of screens or taking shots of screens, which I guess would be a screenshot. So what are we looking at here?
That was a condenser on a supermarket that they had put a VFD on, never tuned it or set it up properly. So that's the saturated condensing temperature. It was going from like 110 down to like 65 degrees nonstop all day long, every day. And afterwards is where I went through and I had tuned it to where it should be to make the drive work properly.
For a little bit, it dropped really low. What'd you do?
Yeah, that was probably me when it was shut off and for me to go through and redo all the drive programming.
Cool. What type of drive was it?
Danfoss drives.
Danfoss drives. I have one bad Danfoss drive story. It's like I have very little grocery cred, and that was just one thing that I had to deal with once, and I just go back to that all the time. I'm like, oh, hey, you're a Danfoss man. Yeah, me too. I had that one time at band camp. All right, so when you're saying variable frequency drive, you're talking about setting up the variable frequency drive for the condenser fans, correct?
Yes. And then tuning it with the EMS controller and the drive itself to make it run properly and efficiently.
So what specifically did you change?
We actually changed the PID inside the controller, the way it is interpreting the signal. And then we changed the speed up and speed down rates of the drive, the way it interprets it in the controller to send the signal to the drive. And then we had reprogrammed every fan motor on the rack so that it didn't cycle off the controller and the condenser anymore. It was cycling off of a custom program that we made to keep the fans from cycling until it was extremely cold.
You like to make custom programs. That is one thing that I know about you. All right, it's acting weird again. There it is. All right, so what are we looking at here?
To be a phase loss monitor.
A phase loss monitor. Why do we have a wire off? I can see from here what's wrong with it. It's busted. The wire's off.
That would be how I found it at 2:00 in the morning.
Oh, that is literally how you found it.
Yeah.
Oh, okay. Why? It just popped off?
Somebody didn't tighten it good enough, and the vibration, it just finally wiggled itself loose and popped off.
Huh. Nice.
So it looks like that contactor's pulled in. So.
Oh yeah. Yeah.
So was it just throwing a phase loss? No, it couldn't have been.
It was throwing a phase loss on the controller, but the contactor still pulled in because this is a Hill Phoenix rack and they're using a relay. And the contactor still pulled in because one side of the relay was welded shut. So they were using a relay. They had a double pull, double throw relay. One side of the relay was welded shut for the control voltage. The other side of the relay was sending a signal to the controller to shut down, but it wasn't set up to shut down the compressors inside the controller, just the alarm for phase loss.
Oh. Okay. Well, it's a good thing you didn't actually have phase loss, I guess.
Oh, it did. It blew the main breaker.
Oh, okay. It did have phase loss. Great. All right. So let's talk about that for a second. So, Jeremy,
Yes, sir.
phase loss for people who aren't used to working on three-phase equipment. Give us a quick rundown.
Okay, so three-phase equipment to get basic is the same 60 hertz electricity that we're used to seeing. Just each of the three phases are 120 degrees out of phase with one another. So if we lose one of those phases, or they become out of balance if the voltage doesn't, see it displays phase average there. If that average goes too far out of, or if it goes too far out of spec, if one line drops too low, then that can be problematic and cause three phase to run hot. So we want to use that to shut the machine down as a safety.
Yeah, and that's why what we're seeing here is, there's nothing going out the load side of this. It's just monitoring one side. It's just monitoring line, and it's designed to open up and shut it down if you have a loss on any one of these phases, or if any one of these phases gets too far outside of the range, or if your voltage gets too far out of range. So it's doing a lot of different things at once.
Right. And that device will actually monitor on the load side there. You can actually set that up to monitor both incoming line and outgoing load. So like if a set of points went bad in the contactor, so you had a very large, very expensive motor, you could set that up to monitor both incoming and outgoing voltage on your motor starter.
Yeah, and you'll see this a lot on just typical, 208 three-phase rooftop package units, that sort of thing. This is actually one of my favorite phase monitors. I don't know if you guys have a different favorite, but I worked with this phase monitor for 20 years. And
it's the one I carry in my truck because I can use it for everything.
Yep. And what's interesting is, for those of you who hear me talk about the ICM 493, the ICM 493 is the residential single-phase version of essentially the same thing. You just don't have to do the phase loss monitoring. You're only looking at over and under voltage. So it's sort of a stripped-down version of this. Cool beans. Somebody asked, or Steve Wright asked, is this a 480-volt rack? I certainly hope so.
I believe so, probably.
Yeah, I hope so. Otherwise, we're in trouble. All right, so here's more Kevin stuff. What are we looking at?
Everything.
Look at all this stuff. Would you look at it? Would you just look at it?
That would be a microthermal controller in a CO2 supermarket. So this is a transcritical CO2 rack.
Nice.
So this is the layout and of the PLC with all the readings, the pressure readings and temperature readings, and what everything's doing on the screen, and what everything's running at, and all the pertinent data you need to troubleshoot everything.
So this is interesting. So it's actually monitoring space CO2 in the space itself?
That would be in the rack room, on the rack. So it's monitoring the CO2 level inside the rack room. So
okay.
If it gets too high, it'll shut down the machine and turn the exhaust fan on, trying to ventilate the area.
That means you're doing pretty good, because that's pretty close to regular CO2 levels, outdoor CO2 levels. So you don't have any big hissers in there. So that's good. Cool. Yeah, this is a lot to look at, but you can kind of get a sense of the parallel nature, of a parallel rack. Even here, you can see, 1, 2, 3, everything's paralleled in together. Oil separator, oil reservoir, flash tank. Flash tank is a really interesting concept in these instances. Do you want to talk about that real quick?
So it's technically it's a receiver, but it's not a receiver. So it still holds the liquid charge for the store, waiting for the valves, until it needs them. It still keeps our minimum liquid level, but at the same time with CO2, once we get above an 87 degree condensing temperature, we no longer are a liquid, a vapor. We no longer have that PT relationship. It's kind of an unstable gas. So what we have to do is we have to reduce the pressure in that receiver/flash tank in order to create liquid again. So I may be running like 1,600 pounds of pressure on my discharge going through my gas cooler. When it's below 87 degrees, it's a condenser. When it's above 87 degrees, it's the gas cooler. It just de-superheats the gas. So it's going to de-superheat it. And then there's a valve on there. If you zoom in, it says ICMT valve. That valve is like a holdback valve, but it serves another function. It works in unison with the valve coming off the tank. It says flash gas bypass. So one valve closes, the tank bypass valve will open, and what it does is it holds back and vents off that tank to the medium temp compressors at the same time, and that allows the CO2 to then change from this unstable gas vapor mix back down to a stable liquid that we could use to refrigerate in the store.
Yeah, and so you can see currently this valve is
remaking liquid.
You can see right now this valve is at 49% open, and so our discharge pressure is 657 because it's cold outside, and at least cold by Florida standards. And then inside the tank, it's 494.7. So you can see there's a pressure drop going across this valve even right now, even though everything is in the regular, kind of liquid state. It's not you don't actually have anything changing state from that supercritical fluid back down to liquid in here. But that's why it's called a flash tank rather than just a regular receiver. I always think that's interesting. Did I say anything terribly wrong right there? I think I might have called this the discharge line instead of the drop leg. Drop leg, which that's one term that I want to, because that was one that I was confused by, because I always called that the liquid line, but you call this the drop leg. Why is that?
Because it's dropping out of the condenser. And it's liquid's dropping out of the condenser, and it's going to the receiver.
So even though it is liquid, refrigeration guys call this a drop leg, the line that's in between the receiver and the condensers, and then the line that goes between the receiver and the expansion valves you call liquid lines.
Yes.
Correct.
All right. You notice how I say you, not me, because I don't count myself in your lot. I haven't sacrificed to the degree. I haven't given up a marriage yet to be a true rack refrigeration technician. That's not funny. We're trying to get people interested in being rack technicians. All right, what are we looking at here? I don't even know what we're looking at here, frankly.
So that would be a set of drop leg check valves coming from the roof of a supermarket that on the drop legs from the condenser. So those check valves are there so that when we split the condenser in half in the wintertime, the liquid refrigerant doesn't flow back upstairs on the split side coil, because we have a ball valve with a motor on it that shuts off one side of the condenser. In this case, this is actually two 10-fan condensers. So this is a huge rack. It has two 10-fan giant condensers, and we shut off one condenser at 50 degrees, and we pump all the refrigerant out, and then we run the other condenser. Well, those check valves keep everything from going back upstairs. And what you do to one condenser, you have to do to the other condenser. So you have to equally pipe both of them. So that's why they both have check valves. And in this instance, that check valve right there had to get cut out and taken out because it was stuck and bleeding through. And somebody had put an extra 600 pounds of gas in the rack that was stuck in the winter condenser when it was like 10 degrees outside.
Well, what's 600 pounds of refrigerant between friends? That's what I always say.
He literally always says that.
I do. I'm known to say that. All right. So what do we got here?
That would be a new style Westermeyer oil filter that they had sent me for testing.
Do you like it?
So far, yeah. We put one in. It's worked out so far. It's a little nicer than the Sporlan style because you don't have to take the flare nuts off the top to change the filter. You could just change the filter, just pull the lid off. You don't have to go pull the flare nuts off and risk junior tech or somebody over tightening the flare nuts and cracking a flare and getting oil everywhere.
I have a Westermeyer story. I went to dinner with the Westermeyer trainer at Outback in little old Claremont, Florida, where we are. And he brought somebody with him. And I said, hi, I'm Brian. Who are you? He said, I'm Gary Westermeyer. He said it just like that too. And I was like, oh crap. So he actually came and did the class at our office, which was great. We have a video on oil management on YouTube. Not that I'm bragging, but I'm kind of a big deal. If Gary Westermeyer visited me, that's all I'm trying to say. So Nathan, you care to add anything to that incredible story I just told?
No, it was a really nice class.
It was a nice
delightful
class.
People.
Yeah, they were. It was very very nice of them.
Right,
I haven't talked to him since, but
being his son-in-law, so that's sort of why I think he came.
Right. It was Orlando, son-in-law. Yeah. Which, hey, I want to think it was all me, except he had no idea who I was. So it wasn't that. It was just a coincidence. But it was very nice of him to do that.
He also looked a wee bit like Farmer Hoggett from the movie Babe.
Okay. Moving on. Oh, I think we got a little bit of customer stuff up there in the corner. So we're going to go ahead and cut that out.
Just as quality meats.
It does. It does. We may be able to beat their prices, but anyway.
Don't worry about it. It's an independent.
Okay. All right. Fair enough.
This is actually a store that we just started. The floor started heaving.
Heaving.
So, yeah, it started.
Oh, I see it.
Oh, yeah.
The cases are actually splitting apart. They're actually like 4.5 inches difference now, like as of this week.
Oh, wow.
So you can see like the one case is starting to drop off the floor. They ran the underground. You could see like right at the edge of the green tiles, you could see the underground. They just ran the suction lines in a pit and poured sand around them with no Armaflex.
Okay.
And then the drains froze and filled the pit with water. Now there's giant ice balls, so it's all getting re-ran overhead.
Actually, I think we had this conversation. You were saying that a lot of new stores are still being built with pits where you are, right? Undergrounds.
Some, yeah. Most of this stuff we do is, and it's shorter runs, maybe 20, 30 feet at most, if they do it. But most everything now is being dropped overhead. Like, we're dropping every one of these lines overhead into the cases. So everything's getting false column, and they're dropping everything down PVC chase.
Yeah, that's pretty much all we're seeing now. We had all kinds of nightmares in the past with issues underground, leaks underground, with one of our customers who did a lot of that. Yes, and Nathan pointed out in chat that, Kevin, you did say doo-doo. Just, I don't know if you know that you said that, but fair enough. All right, what's next? This is bad.
That's really bad.
Yeah.
So that was so we've talked a little bit about oil management. This is an oil separator that was installed on a rack system. Long story short, that was less than 6 months old when I pulled it out and cut it apart and took that picture. Was obviously a hermetic. So most common oil separators, you can take that element out, this piece that you see that's damaged there. You could just take a flange off like we would open up the liquid shell, take that out and replace that element. In this case, you had to replace the entire separator. We wound up this was undersized, which is what caused it to rupture the way it did. We wound up upsizing that, and the customer has had no problems in almost 2 years now since that job was done and that picture was taken.
Nice. So how did you go about diagnosing it?
So you would measure a pressure drop across that, and it should have, I would say, a minimum of about 2 to 3 pounds of pressure drop. When you start to get up around 10 to 13 pounds of pressure drop, it's time to replace that element, or in this case, replace that entire item. This had no measurable pressure drop across it, which, now that you can see it, right, is obvious. As far as the sizing, we had to get down into the displacement of the various compressors, not so much tonnage. You can do it with tonnage, but you really want to start talking about cubic feet per hour and total displacement of the compressors to get a proper read on sizing the separator.
How much total refrigerant are you moving?
Right.
Cool. All right. Let's see what else. We'll do one or two more, and then we'll wrap this thing up. I know for you guys, it's sort of like, we're not really covering anything in sequence here, but keep in mind what we're doing here is we have a lot of people who are supposed to go to trade school and it's canceled, and so now they're spending time at home, and that's mostly who we're talking here to, are people who are maybe enrolled in trade school and now they can't go, or people who are maybe they're laid off, maybe they're in residential and they want to get into commercial. So we're just kind of giving them a view of things that they normally wouldn't get a chance to see. What are we looking at here?
So that would be a vane anemometer that you're using to measure airflow in a case coming out of the honeycombs, which supply the air curtains for the case. So that we're using that to measure the feet per minute coming out of the honeycombs, checking for fan motors out, or checking to make sure the case is the right feet per minute per spec. Make sure somebody didn't put the wrong fan motors in, or it's basically how we check airflow instead of using static pressure, because we can't really use static pressure. We have to use we don't really have any static pressure on these coils, so we use the vane anemometer.
So it's just giving you velocity, and is that actually specified by most manufacturers, or do you just kind of have an average target that you're looking for?
Some manufacturers are way better than others at speccing it and putting it in their manuals. Some manufacturers make you call and beg and plead for it. It just depends on the manufacturer.
Is there like a secret handshake that you use in order to get information, like a password, anything like that? No.
Haven't figured that one out yet.
Okay, fair enough. It's not hoarfrost, is it?
No, not in there. No hoarfrost in there.
Okay, all right. That came up. Just so you guys know, that's not a bad word. It's just it's HOAR. It is I don't know, a natural anomaly. Or not really anomaly, just a natural occurring thing. All right. All right. What are we looking at here? I need to stop saying the same thing every time. So here we have a liquid level gauge. Comment.
Right. So this is basically your fuel gauge, if you want to look at it that way, for your receiver. And that tells you, I mean, it's basically just how full your receiver is. So this one's just a bit over 60%. Now, the weird thing to really, you know what, I'm not even going to go down that road. I was going to get into, it says percentage of pump down capacity. You only want to fill these to 80% like you would fill anything. So it's 60% of 80% full.
Right.
But we would just say that receiver is 60% full.
Right. So that just means that from a rack technician's perspective, this thing's pretty daggone full, because it's not like you can go much fuller than that without risking getting over 80, which is a no-no. Because you should be able to pump down the entire rack.
All winter. Like up by us, that's generally what we run ours all winter within split condensers, 50 to 60%.
If it's in split condenser, that's not really that full. No.
Got it. Okay. One more, and then we have to call this party to an end. I know you guys are having a blast, and you never want it to end. But this is, I think this is yours, Jeremy, isn't it?
I don't think so.
No, it's leaking.
Yeah,
that's what we know for sure.
Little leaker there.
Yeah, and this is the EPR that we were talking about before, evaporator pressure regulator, and it's a really big part of rack refrigeration, and it is part that when I started walking into rack rooms, I had the hardest time getting my head around. What is some good? So for somebody who's interested in learning more about rack refrigeration, maybe EPR valves, compressors, all that sort of thing, what are some resources you would send them to? That's what we'll end with. Give me a few of your favorite resources.
Honestly, if I have to pick a single resource, go ahead, Kevin.
I think it's Dick Weir's. That's a really good book. It has a lot of good stuff in there.
You're talking about Dick Weir's book, Commercial Refrigeration for Air Conditioning Technicians? Yeah, that is a good one.
Yep.
That's a good starting point for people who have done AC and want to learn more. That's one of the places I started. What were you going to say, Jeremy?
I like the Sporlan website. It's well organized, and it may not get so much that the Commercial Refrigeration book is a great book, but if you want to get deep into how that valve works or how any of these valves work, the Sporlan paperwork, the Sporlan manuals are a great place to go to learn how a TXV works, how this EPR works. You've got 3 opposing pressures going on here. Plus you've got, some springs and whatnot working against. That book diagrams it out and shows you exactly what each pressure is doing and what is happening in that valve, so you can kind of get a good handle on how the valve works.
All right, Nathan. Any resources? Nathan doesn't really know how to read, so it's always a little bit of a problem.
Say what?
Nothing. Go ahead.
Oh, that I don't know how to read?
Yeah.
So Jeremy Smith frequently will post his own Google Drive drop of assorted manuals and things.
I don't think you're allowed to share that one. I don't think that's what we're doing right now.
Please share it. Share it to anyone and everyone who needs it.
Okay. All right. Fair enough. I didn't want to share your Google Drive.
I have multiple copies. It's
not especially organized, but there's a lot of good stuff in there.
Nice. Well, I'll leave that up to Jeremy if he feels like sharing that with anyone. You can find Jeremy easily in the. There's a couple refrigeration groups he hangs out in. The Refrigeration Brotherhood, I think, is one. That's one you're in, right?
Yes.
Yeah, that's a good one. And then HVAC School. He's one of our longtime contributors and admins. So yeah, then we'll just end there. Thank you all for participating. I know these are a little bit different, a little bit disorganized, but this is how technicians talk. We just talk through stories, and I figure it's easier to talk through stories with images. You can find everything we do at hvacrschool.com. Join the Facebook group. That's a good place to hang out with all of us and ask questions and learn more. Listen to Jeremy's archived podcast. If you go to the website or in the app and just type in Jeremy Smith, you'll find some of his older podcasts and articles. It's been a while since he's been on, but I'm really glad to have you back. Not that Kevin is mincemeat, but Kevin's been on a couple times since I've been able to talk to Jeremy, so it's just kind of a big deal talking to you again, brother. I do appreciate you all coming on. This is the part where you say thanks for having me. Have a great
thanks for having me.
Yeah, you're all right. Great.
Apologize, I was distracted for a moment. But yeah, thanks. I'm happy to help and happy to share the things that I've figured out over the years.
All right, great. Absolutely. The book is Commercial Refrigeration for Air Conditioning Technicians from Dick Wurs. Somebody asked that again. There's a lot of good books out there. Commercial Refrigeration. It's great to go to the manufacturers. Sporlan is a good one. And then also the Copeland mobile app, and their bulletins are also really great. Thank you so much, gentlemen. Hope to talk to you again soon. Have a great evening and stay safe out there.